What's going on, guys? Today I'll show you the power of electrochemistry by use of a PowerPoint presentation. Now before I go any further, electrochemistry is the study of chemical processes that allow electrons to move. This movement is known as electricity, and it can be generated by the movement of electrons from one element to another in an oxidation-reduction reaction, also known as a redox reaction. Now in this galvanic cell, I have the elements magnesium and zinc. Also known as a voltaic cell, the galvanic cell is capable of transferring electrons in a redox reaction. For this cell, the magnesium bar is submerged in aqueous magnesium sulfate, and the zinc bar is submerged in aqueous zinc sulfate. The bars themselves are considered electrodes, and the solution itself is called an electrolyte. The magnesium would be considered the anode because it's higher up on the activity series chart compared to the zinc, which means zinc has to be the cathode. And even though they function differently, both the anode and cathode are considered electrodes. The anode is where oxidation takes place, and oxidation means the removal of electrons. The cathode is where reduction takes place, and reduction is the gain of electrons. And looking at a single container that has the electrode and the solution, it is considered a half cell. So this right here is a half cell, and this right here is considered a half cell as well. Okay, the first thing I did was I gathered my zinc and my magnesium solutions in separate beakers, and I then placed a salt bridge which was soaked in potassium nitrate, and I placed it in both beakers. Now looking back at this diagram, the cation potassium from potassium nitrate, that will move to the cathode, zinc, and the anion nitrate from potassium nitrate, that will go to the anode. Also, the electrons flow from the anode magnesium to the cathode zinc because electrons have a negative charge and they will be attracted to the positive end of the battery, which is the cathode. Now I also placed the magnesium and zinc electrodes in their respective solutions. The black wire was hooked up to the magnesium electrode since it was the anode, and the red wire for the voltage meter from the voltage meter was hooked up to the zinc electrode since it was the cathode. And by using my computer and this software called Pasco Capstone, I discovered that my battery produced a voltage of 0.47 volts. And I was expecting a higher voltage when I did the cell potential energy, but I feel the reason why it wasn't as high as it should have been was because other people used the materials before I did. Not only that, but I also looked at the half reactions. So for the oxidation half reaction, I have magnesium 0 yields magnesium 2 plus 2 negative electrons. For the reduction half reaction, I got zinc 2 plus 2 negative electrons yields zinc 0. And since there's two of the same thing, you got two negative electrons, they both cancel each other out and they're considered the spectator ions. So the net ionic would have to be magnesium 0 plus zinc 2 plus yields magnesium 2 plus zinc 0. And for cell potential energy, I found out that magnesium had a voltage of negative 2.37, but since it's the anode, it will change to 2.37. Zinc has a voltage of negative 0.763, and when I added these together, I got 1.607 volts. Changing concentrations and mix-ups. So if the concentration of the solutions change, it will affect the voltage of the battery. For example, if the concentration of one of the solutions increases, the voltage will also increase. This is due to the ions, since an increase will create more charges. If the concentrations are decreased, the voltage will also decrease. Looking at my battery alone, if the concentration of magnesium ions are increased, the mass of the anode will decrease, and if the concentration of the zinc ions are decreased, the mass of the cathode will increase. Now, if the metals are placed in the wrong beaker, the battery's voltage will go down to 0, and this will throw off the flow of electrons and will have a less concentration of each substance. How does the salt bridge and duration affect the battery? Well, potassium nitrate will be used more often than potassium chloride due to the solubility rules. All nitrates are soluble, so potassium nitrate would be the first choice. And even though chlorine is also soluble, if it's paired up with copper, silver, mercury, and lead, it will be considered insoluble. And if it's insoluble, it can cause a precipitate on the bottom of the half cell, which decreases the voltage. So if one of your elements were one of these four, and due to single replacement, if it was paired up with chlorine, you would get that precipitate. And over time, the salt bridge will dry up the potassium nitrate, which is supposed to connect the current of the battery. If the cations and anions are unable to move from one solution to another, the battery will stop working. So one thing I thought was interesting was finding out how well lithium-ion batteries are. These batteries are commonly found in devices such as your cell phone and your laptop, and they're about 2 times stronger than nickel-cadmium batteries since the transition metals are very close to each other on the activity series chart, where you will look at lithium is at the very top of the chart and is highly reactive, meaning it can create a stronger battery than the nickel-cadmium. They're also capable of completing many charge and discharge cycles, but there are still some disadvantages to this battery because they do not work well with high temperatures, and if they're exposed to high heat, they can degrade much faster. It can also possibly result into flames if the battery fails. So that basically sums up my whole project, and hopefully I thought you thought this was fire too.